So hello guys, I'm your Dinesh. In today's lecture, we will go ahead with the topic and we'll be seeing the topic graphical method of solution of a pair of linear equation guys. In the previous two lectures, that's in lecture 1 and lecture 2, in lecture 1 we saw the introduction of pair of linear equation in two variable, and in lecture 2 we did the exercise 3.1, that's the first exercise of this chapter. So before coming to this lecture, make sure that you watch those two lectures first and then you come to this lecture guys. So in the previous lectures we learned how to how to come to a linear equation in two variable from the conditions given in the question and how to represent them graphically. That is, we learned how to get the pair of linear equations algebraically and how to represent them graphically. Now we are going ahead and seeing graphical method of solution of pair of linear equation. Now in the last we learned how to represent them. Now we are going to learn how to find a solution from the representation graphically. Let's go ahead guys. So when it comes to a pair of equations, as we have seen in the previous lecture, there are three cases possible. We have seen in the previous lecture, right, there are three cases possible. The first case is the lines may be intersecting. The second case is the lines may be coincident. And the third case is the lines may be parallel. Yeah, this we saw in the first lecture. It's coming again guys. But here we are going to study when these conditions will be there. Like for what values of A and B, the lines are going to be intersecting. And for what values of A and B, the lines are going to be coincident. For example guys, let's understand the example, then it will be easy. Let's take this pair of equations. The equations are x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. Now as we know, this value is A, right? This is A1, this is B1, and this is A1, and this is A2, and this is B2. So the condition is we have to take the ratios guys. We have to take A1 is to A2 ratio, B1 is to B2 ratio, C1 is to C2 ratio. First let's take the ratio. So A1 is to A2 ratio is 1 by 3, B1 is to B2 ratio is minus 2 by 4, and C1 is to C2 ratio is 0 by minus 20. Now if you compare the ratios, you will get to know that A1 by A2 is not equal to B1 by B2, right? A1 by A2 is not equal to B1 by B2, which means in the graph, if you plot the graph of these two equations, the lines which you will be getting are going to be intersecting lines, which means they are going to have only exactly one solution, right? This is the first thing which you have to understand. This is the first condition which you have to understand. The second condition, let's understand with the other two pair of equations. It is 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. If you take the ratio A1 is to A2, here you will get 2 by 4, right? This is A1. As you know, the general equation is A1x plus B1y plus C1 equal to 0, right? And the general equation for this equation is going to be A2x plus B2y plus C2 equal to 0. So comparing the coefficients of the variable term, we'll get to know that this is A1, this is A2. So A1 is to A2 is going to be equal to 2 by 4 in this case. B1 is to B2 is going to be equal to 3 by 6 in this case. And C1 is to C2 is going to be equal to minus 9 by 18, right? So if you see in this case, yeah, it's going to be minus 9 by minus 18 as well. Both are minus sign. So minus gets cancelled, it becomes plus. So if you see in this case, what happens is all these ratios are same. A1 is to A2 and B1 by B2 and C1 by C2, all these ratios are same. 2 by 4 is nothing but equal to 1 by 2, right? It's 1 by 2, the ratio, the simplest ratio of this one is 1 by 2. And similarly, even the simplest ratio for 3 by 6 is 1 by 2. And 9 by 18 is also nothing but equal to 1 by 2, which means all three are 1 by 2, which means A1 by A2 equal to B1 by B2 equal to C1 by C2, which means in the graph, these two equations are going to give us coincident lines. Coincident line means in the graph it will seem like only a single line. Both the lines will be present along the same line, right? So how many solutions are you going to get for these equations? So we can conclude from the graph that we are going to get infinitely many solutions for these two equations. Now let's go and see the third case. The third case, the example they have taken is x plus 2y minus 4 equal to 0, 2x plus 4y minus 12 equal to 0. Now if you take the ratios, Similarly, how we took for the previous cases, a1 by a2 you are going to get 1 by 2, b1 by b2 you are going to get 2 by 4, and c1 by c2 you are going to get minus 4 by 12. In this case, what's interesting is a1 by a2 is equal to b1 by b2. Okay, this ratio is equal to this ratio, no problem in that. But when it comes to c1 by c2, it is not equal to c1 by c2. This ratio is not equal to the other two ratios. That is, the constant terms ratio is not equal to the coefficient of variable terms ratio. Getting it? So here the comparing the ratios will get a1 by a2 is equal to b1 by b2, but it's not equal to c1 by c2, which means it is going to have parallel lines. If you draw the graph of these two equations in the graph, you are going to get parallel lines. So in a parallel lines, it implies that it's not going to have any solution, which means these two equations doesn't have any solution, so it's no solution case. These are the major three cases which you have to remember, guys. Not major, these are all the three cases which you have to remember. If you know all these conditions, it's going to be really easy to proceed in this chapter. So I'll move aside now. You can take a screenshot, guys. Of that we'll see few examples related to it. So guys, after learning the basics, let's go ahead and see the example 4 of this chapter. That is, check whether the pair of equations, these two equations they are given us, we have to check whether it is consistent. If so, solve them graphically. First let's check if they are consistent, guys. So how to check them first? Let's check it here. If a1 by a2 is not equal to b1 by b2, which means the equations are going to be consistent. So a1 by a2 is 1 by 2 and b1 by b2 is 3 by minus 3, which is nothing but equal to 1. Is 1 by 2 equal to 1? No, it's not equal to 1 by 1. So a1 by a2 is not equal to b1 by b1, which means the equations are consistent. Now let's go ahead and draw the graph and find the graphical solution for this question. To draw the graph, as we have done in the previous chapters and the previous lectures, we have to take the value of x and y and then put the value of x and get the value of y, and then you are going to get the coordinates which you are going to plot it in the graph and then join them and draw the line, find the intersection point to find the solution of the question. So we have taken this equation, guys. This is for the first equation, right? This is for the first equation and this is for the second equation. These two tables, we have put the value of x as equal to 0, y value we have got it here. I think by now you people are quite comfortable with this tabulation part. So here we get the value of x and y as 0, 2 and 6, 0. With this 0, 2 and 6, 0, let's write it here. 0, 2 and 6, 0, we are going to draw a line. 0, 2 is here and 6, 0 is here. If we join these 2 points, we are going to get, this is the first point, this is the second point. If we join these 2 points, we are going to get the first line, which is the line of the equation x plus 3y equal to 6. Now let's go to the second equation. Second equation value, if you put the value of x as x and y, if we get the values, the coordinates which we get are 0, minus 4 and 3, minus 2. Now these 2 points, now if you plot in the graph, you are going to get 0, minus 4 and 3, minus 2, right? Yeah, 3, minus 2. So when you connect them, you are going to get a line like this. If you see the intersection point is at the point 6, 0. So always the solution for the equation, any two equation graphically, is the intersection point of the lines. It is that point where the lines touch each other. So these two lines touch each other at the point 6, 0. So 6, 0 is the solution of these two equations. Finally, you will conclude by writing, hence the solution of these two equations are 6, 0. Value of x equal to 6 and value of y equal to 0 is the solution of the question. Now let's go to the next example. You can take the screenshot now. So guys, now let's go ahead to the third example of your NCERT textbook. Let's read out the question now. The third example says, Champa went to a sale to purchase some pants and skirts. When a friend asked her how many of each she brought, she answered the number of skirts is 2 less than twice the number of pants she purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Help her friend to find how many pants and skirts Champa brought. So guys, this is the question. So some Champa goes to a shop and then she buys skirts and pants, and then they are given us the conditions. Now those conditions which are in the verbal form, we have to convert them into a mathematical form and form them into equations. From those equations we have to plot the graph, right? Let the first step in this type of question is that assumption, right? So let's assume first, guys. Let us denote the number of pants by X and number of skirts by Y. So going by the condition, she says the first condition is the number of skirts, right? They are telling about skirts. So the number of skirts is 2 less than twice the number of pants. So number of skirts is 2 less than twice the number of pants, means Y equal to skirts equal to 2 less than twice the number of pants. Done. First equation is done. They are saying the number of skirts equal to 2 less than twice the number of pants. Number of pants is X, right? So 2 less than twice of number of pants, that gives us Y. That gives us number of skirts. From the first sentence we form the first equation, right? Now let's see the second equation. The second equation tells also the number of skirts, again they are talking about skirts itself, is 4 less than 4 times the number of pants purchased. It's same, guys. Here it was 2, right? Here it's going to be 4. So number of skirts equal to 4 less than 4 times the number of pants purchased. 4 less than, so you're minusing 4 less than 4 times the number of pants. Number of pants is X. So 4 less than 4 times the number of pants equal to Y. This is the second equation. So 2 equations formed, right? From these 2 equations you are going to form the tabular columns. In tabular columns, here it's going to be X, here it's going to be Y. So Y equal to 2x minus 2, and here it is Y equal to 4x minus 4. As usual, how we used to plug in the values of X and get the values of Y, we are going to put the values of X as 2 and 0. We are going to get 2 and minus 2 respectively for the first equation. And for the second equation we'll be getting, like, we'll put the values 0 and 1. For example, if you put 0 here, it becomes minus 4, right? You're getting minus 4 as the value of Y. And when you put the value of X as equal to 1, you are going to get the Y value as equal to 0, because 4 minus 4 is 0. Now let's mark the coordinates. The coordinates are 2, 2 and 0, minus 2 for the first equation. That's the line of first equation. And the coordinates for the second equation is 0, minus 4 and 1, 0. Now if you plot these points in the graph, let's plot for the first equation, guys. 2, 2. 2, 2 is here. 2, 2 is here. Right, 2, 2 is here. And then 0, minus 2. 0, minus 2 is here. Right, this is minus 2, so this is 0, minus 2. So this line joining 2, 2 and 0, minus 2 is the line of first equation, that is Y equal to 2x minus 2. Now let's draw the line of the second equation. In the second equation it is 0, minus 4 and 1, 0. 0, minus 4 is here and 1, 0 is here. Right, so now if you connect these 2 points, you're going to get a line like this, right? So this line corresponds to the equation 2. So these are the 2 lines which we form with the 2 equations. Now, as I said you, the solution, the graphical solution, you're going to get from the intersection point, right? So in these 2 lines, the intersection point is here, 1, 0. Right, the intersection point is 1, 0, which means this point, right? Which means X equal to 1 and Y equal to 0 are the solution of this question, which means the number of pants brought by Champa is 1 and the number of skirts brought by Champa is 0, which means she didn't bring any skirt. The only thing which she brought from the shopping, when she went for the shopping to bring, she purchased was only 1 pant and 0 skirts. This is the final solution, guys. This is how we are going to get solution graphically. So that's it, guys. Now we are done with all the examples. So let me give you a brief glance of whatever we have learned. We have learned that the graphical solution of 2 pair of linear equations we'll get from the intersection point of the graph. That's the first thing. That's the first case. That's the graph will be, we'll get an intersection point in the graph. We'll get something like this. This point, intersection point, will give us the solution of the pair of linear equation. That is when when a1 by a2 is not equal to b1 by b2. If you check this equation also, if you bring it all to the one side and then if you match with that a1 a2 values, you'll know that a1 by a2 is not equal to b1 by b2. That's the condition, right, which we learnt in the previous lectures. We saw a huge table. So the second condition is, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, which means the lines are going to be coincident, right? It will seem like there's only one line, but both the lines will be on the same line. They'll be coinciding lines. Now if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, which means the lines are going to be parallel. They are going to be something like this, parallel, which means they are never going to meet each other. If they are never going to meet each other, then there doesn't exist any solution for such type of questions. This is a quick revision, guys. I think now you are thorough with the graphical part and my explanation and the explanation through examples. Now let's go ahead and solve some exercise questions. Let's go to the next exercise of this chapter, that is exercise 3.2. In that exercise you will be solving these type of questions which will make you more comfortable with this concept and make you completely thorough with this concept, guys. So before going to the exercise, before going to the exercise, I will tell you to practice few questions, and also before seeing the next video, that's the exercise video of 3.2, practice exercise 3.2 by yourself and see once. If you are able to solve the questions, you can do it by yourself. If you are not able to do, you can see my video and then do the questions whichever you weren't able to do it. So now I'll move aside, guys. You can take the screenshot now. So meet you in the next lecture.